Hey guys, today's goal is to simplify zero and negative exponents. Alright, so first let's look at some rules. There are some rules that will help you out in the long run. Alright, so one rule is anytime that you have an exponent of 0, okay, it could be any number to the 0 power. If anything is to the 0 power, your answer is going to be 1. Alright, so that's the first rule. Alright, the second rule, alright, I'm going to put that in like a bubble or something so you know that's one of them. Alright, now the other rule is this. Anytime you have a base and then the exponent is a negative number, what it means is, and that's a negative a, and that could be any number, that means it is the same as 1 over that base to the same exponent. The only difference is the negative is gone. So any any number to the negative exponent is the same as 1 over to the same exponent. The negative is gone. All right, so having a negative exponent does not make the actual number negative. It doesn't do that. It puts it in the denominator. So let's go ahead and try some. Okay, so if we have negative, let me change that. If you have 6 to the negative third power, all right, that's a negative 3. Let me fix that. You know it's going to bother me if I don't fix it. Okay, 6 to the negative third power. What that means is it is the reciprocal. So it's 1 over 6 to the third power. Notice the negative is not there once you put it in the denominator. So actually a negative exponent is really the reciprocal. So if it's 6, it's going to be 1 over 6. And then the exponent becomes positive. And so you would answer it as 1 over 216. Because 6 times 6 is 36. 36 times 6 is 216. Okay, let me give you another. This is going to practice our 0 rule. Negative 4.6 to the 0 power. Remember, anything to the 0 power, no matter what it is, if it's a decimal, if it's a fraction, or if it's a whole number, it's going to be 1. Okay? Now I'm going to step it up a little bit. Let's say that you have a number with variables. And the only exponent I'm going to put here is right with the y. So you have 3x y to the negative 4th power. Now that negative 4, it's only attached to the y. It's not affecting the x, it's not affecting the 3. That negative 4 is only attached to the y. So what happens is your 3 comes right over, you don't touch it. Your x comes over, you don't touch it, because the exponent that it has is 1. It's when you see no exponent, the exponent is 1. So 3 to the first power and then x to the first power. So, but now we've got y to the negative 4. Well, we can't have that, so we need to do the reciprocal of that. So first I'm going to put it in a parenthesis so you can see what it looks like. 1 over y to the 4th power. Then you close it. Now, typically we do not leave it like this, so don't get in the habit of leaving it in this format. What you do is you have a numerator and you have a denominator now. So let me rewrite it. This is really saying 3x over 1 because it's in the numerator. Anything over 1 is just the same thing as it not having a denominator. Times 1 over y to the 4th power. All right? So if we were to combine everything, let me bring it on down. 3x times 1 is 3x over 1 times y to the 4th power, y to the 4th power. So that's your answer. So look at the beginning. Look at your original question. 3x, y to the negative 4th. We took the y and we put it, we did the reciprocal of it, 1 over y to the 4th. And then we put our original 3x over 1 times 1 over y to the 4th power. And then we just multiply straight across. Let's try another. All right. 4a squared b to the negative 3rd power. Okay? Now, remember, if you've got a negative exponent, you automatically have to flip it to the bottom. All right? And I'm going to add something else to that. I'm going to say where a equals 3, and let's say that b is going to equal negative 2. All right? Let me just put that over to the side there. All right, now let's go ahead and use our rules that we have so far. So we have 4a squared, and now I know I'm going to have to change that b to 1 over. So I'm going to go ahead and do this, 1 over b cubed. Now, I know that my 4a squared, that's in the numerator, so I'm going to go ahead and put that in the numerator. So 4a squared, and then I'm going to put that over b cubed. All right, so that would be our answer. However, we have a equals 3 and b equals negative 2. So now we have to substitute in and get that. So 4a is 3, and then that's 2 over. B is negative 2, and then that's a 3 as your exponent. I'm going to go across. That's going to be 4 times 9. You can't multiply 4 times 3 first. You have to do the exponent first. So that's 4 times 9 over negative 2 times negative 2 is a positive 4. Positive 4 times another negative 2 is going to be a negative 8. Remember, you have an odd number of negatives. You have a negative times a negative times a negative. Remember, when there's an odd number of negatives, your answer will be negative. So that's going to be 36. 4 times 9 is 36 over negative 8. And then let's just simplify. Let me see. Our greatest number that goes into both 36 and 8 is 4. So let's just divide by 4. All right. And that's going to give us 9 over 2. And it is negative, because you have a 36 and a negative 8. So the answer is going to be a negative. All right, last one. All right. Let's see. Let's say that you had to take this 1 over 100, and the directions are to write using negative exponents. Let me fix that. Okay, so first you have to change 100 into exponential notation. So it has 2 zeros. So that means it's going to be 1 over 10 to the second power. Remember, the amount of the exponent when you're dealing with multiples of 10, the amount of zeros tells you the amount of exponent that you should have. So that's 1 over that. Now, it's already 1 over 10 to the second power. So if I were to bring that back out and kind of work backwards, then the reciprocal would be 10 to the negative 2 power. Okay? So remember, we will be practicing these in class. Another one that you might see, because 1 over 100 or 1 over 1,000, those are pretty common that you might see. Another one that you might see is when you have multiples of 2's, because you're expected to know like your multiples of 2's pretty easily. So let me just try to give you one. Let's say 1 over, let's do 16. All right. So 16, how many 2's does it require to be a 16? Well, if I had to break this down and we do our prime factorization, I would do 4 and 4, and then it would break down to 2 and 2, 2 and 2. And you can do this with any set. Just go to the side and break it down and see how many multiples of that particular number that you're going to have. So we have 4 2's. We have 1, 2, 3, and 4. So what that means is 1 over 2 to the 4th power, right? Now, being that this is in the denominator and I want to bring it out of the denominator because the directions are asking to use negative exponents, then I bring it out of the denominator and then I put the negative with it, all right? So we'll be practicing this more in class. Make sure I'm going to go ahead and do this. Put an X and put a line. Please go get your parents' signatures right now. Okay, have a good afternoon.